Hello everybody. In the series Basics of Life, today we look at Europa and if Europa would be a good place to look for life. First, some general properties of Europa and then why is it implied in life discussion. Europa has been discovered by these two guys here, Galileo and Simon Marius, in 1610, when the first telescopes came up. It was kind of logical that the Jupiter's moons would be discovered very soon. In the past, people were talking about Galileo a lot and not so much about Marius, but Marius was responsible for naming the moons. Europa is a half-warm moon due to the gravitational influences of two other moons, which is Ganymede and Io. And Ganymede has exactly 2 times the orbital period of Europa, which means it gives it regular kicks. And this heats up Europa. And Europa has exactly 2 times the orbital period of Io. And Io is even hotter. It's not a half-warm moon, but a hot moon actually. Europa's diameter is 3,122 kilometers, so it's almost as big as our moon. And it has a thin atmosphere of oxygen, so the pressure is just 10 to minus the 12th bar. So that's disputable if you even want to call it an atmosphere, but it's very, very thin. It revolves around Jupiter in 3 days and 13 hours. And the mean surface temperature is 102 Kelvin, which is minus 171 Celsius. From the Earth, there are regular eclipses by Jupiter and the other moons. So when Galileo first looked at Jupiter, he could see only 3 moons, because 2 of them were so close together that he couldn't tell them from each other. Europa may have cryogeysers like Enceladus. We talked about Enceladus in the last video. Europa has water, and actually a lot of water. Some 3 times 10 to the 18th cubic meter, which is about double the amount that the Earth has. So you can make an ocean between 5 and 100 kilometers thick. This is a salty ocean, and maybe it even has geysers. We will look at that in a second. Here there's some idea how Europa could look inside. So it may have an iron core, a rocky mantle, and then a water ocean and an icy crust. And this actually explains its surface that is very full with crevasses, very rocked. That's what it looks like. And people say that geysers or plumes have been found in a Hubble Space Telescope image. Here they are more or less. I'm not sure if this is actually the Hubble Space Telescope image. It rather looks like this part of the image comes from Voyager 2 that flew by. I don't think that the resolution is so good by the Hubble Space Telescope. Correct me if I'm wrong. These should be clearly investigated further, these plumes, if they exist. This is what the Europa Clipper mission is going to do. There are 2 probes going to Jupiter at the moment, and it takes them quite a while to get there. Europa Clipper will start investigating in 2031, and this is more or less the aims that it has. So it's a dedicated probe just for Europa. And this is more or less where it's gonna be when it looks at Europa. And it will do a lot of imaging, but also a lot of radar investigation of what is inside Europa. So after that, we'll be rather able to tell what's inside than at the moment. And there is a second, that's an American probe, and there's a second probe going to Jupiter, which is JUICE by the Europeans. But it will look less at Europa than at Callisto and Ganymede. It will be actually the first probe that goes into an orbit of a planetary moon, the first, which is Ganymede. But it will have 2 flybys at 2023, 2 flybys of Europa before going to Ganymede and Callisto. Actually, the reason that it kind of leaves out Europa is the Jupiter itself, because it's very dangerous for probes to be too close to Jupiter. This is also why no probe looks at Io more closely, although it would certainly be quite a look to look at Io and its volcanoes. But that's why it just goes by, flying by, passes Europa 2 times, and then looks at Ganymede and Callisto, which is much safer. But Ganymede and Callisto are, for the discussion about life, probably less important because they have water, but the water is frozen, most likely. There are arguments against life on Europa. They are kind of connected. One is the seafloor probably doesn't have eruptions, so there's no exchange, probably, but we will know that better. No exchange between the rocky mantle and the ocean. That's what Green et al. Say. And likely there is no faulting, which means that there are no habitats at the seafloor, sea boundary, which would be the interesting thing if there were habitats there, to see if somebody is in there. I mean, somebody in terms of bacteria, like our archaea. We will talk about archaea in a later presentation. So the outlook is 2 probes are heading out there. I mean, one is rather going to Ganymede and Callisto. Is it the wrong target? I mean, we have Enceladus, that would be a very interesting target. And we will also have to talk about Miranda later, which is the innermost large moon of Uranus. There we just don't know enough, but it would be maybe the more interesting target than Europa. And how can we tell uninteresting outer solar system moons from interesting moons? This is, of course, in the view of looking for life. One argument is this heating up that has to happen, and so this is the energy source, and there has to be water. But the other thing is also a bit the size of the moon. And the size of the moon was strongly an argument for looking at Europa more closely, because Europa is a large moon, there's a lot of water, so people thought should be interesting. But on the other hand, probably this limits the heating a little bit. I don't know, I mean, has life to have a high energy throughput, or can life just live more slowly and keep and use the energy it has? This is this kind of argument. So this is a last view on Europa with Jupiter in the foreground. And thanks a lot for the attention. Stay curious and keep looking up.